We are at week 9. So we have 2 weeks left in our module. We are moving so fast. Um, like I mentioned, weeks 9 and 10, we don't have any more calculations per se. Now we are at least this week looking at presentation of data, and then next week we are getting into some inferential statistics and looking at some statistical terms. So for the last 8 weeks, right, we have been working on calculations, looking at information that healthcare organizations, they want to know. This evening, we're going to dive into presenting the data. So those who need to know will be able to actually analyze the information and make informed decisions. I do want you to keep working on all your assignments, um, your apply and reflection kind of go bys are already up on announcements. So make sure you stop on over there just to kind of see what this week is all about. And this is all going to prepare you for this week's quiz. Keep in mind, it's not per se calculations. This also means that we do take a break from all that problem solving. And now we're going to focus on different types of data. For those of you who are watching the playback, why is it important to present health statistics clearly? And how does well-presented data contribute to better decision making and outcomes in healthcare? Let's talk about that in the discussion forum. Now, you may notice that you have a Constitution Day activity that's going to pop up. For those of you who are here, I'm going to go ahead and put the information in the chat. For those of you who are watching, I'm going to try to remember to actually put this information in the discussion forum um, section. If I don't, someone please remind me. I'm human, so please just let me know because you guys have from September 9th through September 21st to complete it. It'll open up on September 9th. So just make sure that you do go and complete this Constitution activity by then. Okay. I'm not sure what it is, but I just want you guys to know that that is something that is going to be there for you. For our trivia, what is the smallest perfect number? So we've been doing a lot of different trivias and, finding nuances in math. Well, the smallest perfect number is 6. A perfect number is one where all its divisors, except for itself, sum up to the number itself. So, for example, with 6, the divisors are 1, 2, and 3. Adding them together equals 6, making it a perfect number. It's the smallest such number. And pure mathematics, in its way, the poetry of logical ideas by Albert Einstein. Albert Einstein. It's all about finding beauty and creativity in abstract concepts. Just like poets, they find in language and imagery, right? In both, there is a deep reliance on logical structure and patterns, guiding the pursuit of truth and understanding. So, whether you're providing theorems or crafting verses, there's a similar thrill in uncovering hidden connections and elegant solutions. So, that's just our little trivia and some mathematical wordplay. All right, now in chapter 11, we are presenting data. I'm going to set this up. All right. You're a healthcare policymaker, and you're presented with 2 sets of data on the effectiveness on different treatments for a particular condition. Set A is neatly organized, visually appealing, and it's easy to interpret. Set B is clustered, confusing. Everything's in different ways. When you first look at it, you're getting a headache. Your eyes can't concentrate on just one element. So you have set A and you have set B. Which set of data would you find more helpful in making informed decisions about the best treatment approach? Set A or set B? For me, it would be set A. Because when you're looking at information, you don't want to have to decipher what's in it. You want to save time. You want to reduce confusion. And you want to really help empower decision making. So you're looking at making the most effective strategies for improving healthcare outcomes. So you're looking at set A, which is neat. You in your mind, you can see the vision. And then you have set B, where you're like, I need to take an aspirin because my brain hurts. Well, most likely we would all choose set A. So we get down to our learning objectives for this evening. We have to differentiate and apply terms that we touched on in week one: nominal, ordinal, interval, ratio, discrete, and continuous data. We also have to look at the differences between a couple different tables: bar graphs, pie charts, histograms, frequency polygons, pictograms, which are one of my favorites, and scatter diagrams. And we have to choose which graph would be appropriate for what type of data. So we're taking everything we learned from chapter one and we're just diving in just a little bit deeper. We also look at creating tables and graphs to display statistical information. And then we're finishing up this evening with just looking at preparing the basic elements of a report. Going back to week one, we look at descriptive statistics. These are the most frequently used type of statistics by health information technicians. They are responsible for producing statistics that describe populations like our patients, our medical services. They may even dive into different nursing units and hospital departments. These statistics really do provide an overview of the general features of a set of data and can be presented in a lot of different ways, like tables and graphs that we're going to touch on a little later in this live session. We look at categorical data, well, where data is being sorted into different groups, and it's going to be based on certain attributes, which is referred to as categorical data, putting things in categories. Two types: nominal, we've heard this before, and ordinal. Now, when we look at nominal, okay, and we're looking at the nominal scale, it is the lowest level of measurement where observations are categorized into groups with no particular order. For example, you have true or false, male or female, types of insurance carriers, or patient occupations. That's nominal. When we get an ordinal, we are looking at categorizing things in an ordered way. And the order of the numbers is significant, but not the value of the numbers themselves. So the term ordinal is derived from the word to put something in order. Numeric data, number-based information. It can be statistically analyzed and calculated. Interval data. This is the type of data that represents observations that can be measured on an evenly distributed scale beginning at a point other than zero. So your example, you have 11.3, right? Temperature is another example. The difference between 70 degrees and 71 degrees Fahrenheit is the equivalent to the same difference as it shows you 75 and 76. So far, recapping everything, ratio has a defined 0 point, making it the most accurate type of data. Example 11.4, you have the ratio scale is age. So the difference between two consecutive years would be the same, age 1 and 3, as 55 and 57. It's going to be 2 years. There is a 0 point in that 0 would mean an absence of an age or birth. And someone who is 100 years old is twice as old as someone who is 50 years old. Which is true. Discrete, typically whole numbers. They can have only a finite number of specified values. The number of children in a family is an example of discrete data. A family can have 2 or 3 children, but you're not going to see someone saying, I have 2.25 children or I have 3.5 children. The number represents actual measurements. So we're looking at quantities or counts rather than labels or categories. Now, we consider different examples when we get into numerical data. The frequency of motor vehicle accidents in a specific community, the number of times a woman has given birth, the incidence of new cancer cases in your state over, let's say, the last 5 years, or the total number of available beds in a hospital. Now, when you're keeping track of these numbers, you can make informed decisions that can help improve the safety and well-being of any community, right? It can be something like implementing new traffic laws, providing better healthcare services, increasing hospital capacity, or having access to data where now you have a tool for positive change. So this is why we want to know this statistical information, because it can make a huge difference. Now, data values have a natural order. A higher number of births means a woman has more children, right? The difference between 1 and 2 births is the same as the difference between 4 and 5. The births are going to be whole numbers. But then we have to ask ourselves, why does this even matter? Well, one reason that order of data matters is that it helps us to see different relationships, like how more births generally mean more children. This understanding can really help, again, guide us to make informed decisions. For example, it's like knowing that going from 1 to 2 births has a similar impact as going from 4 to 5. It just simplifies our insight. And of course, it helps with our decision-making process. We look at continuous data. Continuous data are just measurable quantities that are restricted to specific values. Examples include a patient's temperature, a patient's height, patient's age. These variables can, believe it or not, assume fractional values. When we look at continuous observation, it is limited to accuracy. Now, for those of you who are here, I want you to think rhetorically about why continuous observation is limited by accuracy. Like, why? It's like, grab this, which I love because you can be precise and accurate. You can be precise and inaccurate. You can be imprecise and accurate, or you're just really all over the place, right? You're imprecise and you're inaccurate. Now, because of the precision of measuring tools and potential errors, we know that there's going to be some limitation. If the tool lacks precision or there are external forces at play, the data collected may not be entirely accurate. So it's important to be aware of these limitations when relying on continuous observation for analysis or any type of decision making. Continuous data is analyzed by converting it into a range. Age, for example, can be categorized into ranges. Measurements on interval and ratio scales can be grouped. Interval and ratio variables are actually continuous. So we have data display, okay? Now, clear data display is going to be important for effective analysis. We go back to set A and set B, where set A was clear, concise, like we knew exactly what was going on, and set B was just all over the place. Remember, I had to take aspirin because my eyes was hurting because I couldn't figure out where to focus on. When preparing a statistical report, we define objectives. We have our scope by answering these questions. You may see these again somewhere. What information is required? What message do you want to convey? What information do we have available? And are the collected data sufficient? When we answer these questions, the report can then be tailored or customized to meet our audience requirements. And that results in a more effective presentation. Now, Table 11.1 lists information with each row representing one patient. And it's from Community Medical Center analysis showing discharge of patients. And using tables has a lot of advantages, like the ability to present more information. You can list exact values for precision, provide supportive details, require less work that incur fewer costs during preparation. And you maintain flexibility without like distorting the data and making it unreadable. So it's table 11.2 illustrates the essential components of the table. Table 11.3 shows a sample table with now the components are actually completed. So you kind of see your draft, your template, and now you see, so this is what it looks like. This is what goes into it. With a frequency table, we look at the number of patients admitted on each day of the week, and we can see that in table 11.4. So just so you know, this chapter is jam-packed with examples, okay? I highly encourage you to go back through and look at table 11.2, 11.3, 11.4, and read what's extra and read the extra information under them. Now, keep in mind, it's important to follow certain rules while creating a frequency distribution table. One of the major rules is to choose the categories or classes wisely and determine the range for each one. The number of categories chosen should be between about 5 and 15 per the chapter. And it's important that these characters or categories, not characters, categories are well defined and you don't want them to overlap. Each observation should be assigned to only one category. And they advise to create categories that cover equal ranges or values whenever you have the ability to. Now we're going to break down each type of display data and starting with graphs. And you're going to want to be able to differentiate which presentation goes with what type of data display. Graphs are a great way to just present data so that it is quickly visible and you can see the relationships. They may not provide as much detail as tables, but they have a lot of different advantages. Now, you're presenting the data in a form of a graph. It's an excellent way to kind of get your message out there. To create effective and easy to understand graphs, it's important to follow certain guidelines. Now, the chapter provides very valuable insights and those guidelines that can really help you create clear and accurate graphs. I highly recommend y'all going back and reading this chapter just to gain a better understanding of the best practices for creating graphs that are informative. And of course, you want them to be visually appealing. Now, we're going to start with bar graphs. They're known as bar charts, or also known as bar charts. They are a useful way to display categorical data. Now, I'm going to give you some examples of when a bar graph might be used in healthcare settings. And you may have a scenario where they're going to ask you. We're going to look at treatment outcomes first, and then I'm going to move to patient surveys. Now, a bar graph can visually represent the success rate of different surgical procedures for, let's say, a particular medical condition. Each bar could represent to a specific treatment. Now you're allowing healthcare professionals to easily go in and compare and choose the most effective option. And I also wanted to touch on an example of patient satisfaction surveys. Now, a graph can display the results of a patient satisfaction survey. Each bar can represent a different aspect of healthcare experience, whether it's their communication, it could be cleanliness, it could be how long did they wait? Did they feel like their wait time was acceptable? Too long? Just right? Could be improved, okay? This visual representation does help identify areas of strength and areas that may need improvement in patient care. We move to pie charts. Pie charts are useful to display data as component parts of a whole. They consist, of course, of a circle and it's divided into sections, just like wedges or slices like you see on the screen. And the example that I have for this one is looking at disease types. So a pie chart can illustrate the distribution of different types of diseases within a patient population. Each segment of the pie could represent a specific disease category, providing that quick visual overview of the prevalence or looking at various health conditions. But it can also be used for a budget in healthcare, where it's representing the allocation of the facility's budget across different categories, like looking at the personnel, looking at equipment, research, and of course, patient care. Now you have that visual representation that helps administrators and stakeholders really understand where resources are predominantly directed and identify areas for potential adjustments. Our line graph are useful tools for displaying data over time. I'm going to repeat that. Line graphs are useful for displaying data over time. They are commonly used to present information regarding days, weeks, months, or even years. So, bed occupancy. We've calculated this. We're feeling confident. Line graphs can be utilized to track the occupancy rate of hospital beds over time. And that's going to really help the administrators in resource management and planning for like peak periods. But did you know that they're also good for different trends, like the incidence or prevalence of diseases or health conditions in a population over time? And what that does is aid public health officials in identifying trends and planning interventions. Now, why would that be important? Why would we want to track diseases in healthcare and make sure that we're catching these trends when they start to rise or decrease? Why do y'all think that is? So, some things to kind of think about. And I typed in the chat, it could show us that we're doing some things right, or it can also show us that, hey, we're missing the mark and maybe we need to try a different approach in controlling and kind of helping. So the question was, why would it be important to kind of track prevalence of diseases or health conditions in a population, like over time? Like, why would we want to watch it, like watch what's going on? Let's say, for example, let's say COVID-19, right? So COVID-19, hypothetically, let's say in January of 2020, the rate of patients or the amount of patients that had it was, let's say, at 50%. Okay. Then let's say by March, same year, it jumped from 50 to 75 after we put different precautions into place. Well, what would that have told us? Right? To see if the cases are increasing or deaths are rising. Exactly. So, we can have a line graph to kind of show, hey, this is what happened in the beginning of 2020. And now we're not even all the way through. And look where we have increased, or let's say now it's 2020 and we're at 2021 and it started to decrease. So we can kind of say, hey, maybe we're doing something right, or we've got to look and see what we got going on, because it's just not it, right? We also look at histograms. These are a type of representation used to display frequency distribution for continuous numerical data, which can be either interval or ratio. So that's why making sure you guys can differentiate the data display and the type of information it represents, because you may have a lot of different concepts, right? Because this is all about presentation of data. For a histogram, the example that I have is vital signs. Okay. We look at blood pressure. We can look at heart rate. We can look at temperature within a patient population. It does help healthcare professionals quickly identify common ranges and outliers. But laboratory testers may also use histograms because they can also look at things, cholesterol, levels of glucose concentration, which now helps them to understand the prevalence of certain health conditions within a group. Okay. With our frequency polygon, this is a graphical representation of distribution that helps to understand its shape. A frequency polygon in a healthcare setting could be employed to visualize and analyze distribution of some health related data. So it may represent the frequency of patient vital signs within a specific range, specificity. Um, you may be looking at blood pressure readings or even heart rates. Now, they could be beneficial for tracking trends in patient data over time, right? So we're seeing their blood pressure going one way, going the other way. This graphical representation can really help with quick insight. And you're looking at it, and now it's just going to help us with decision making and patient care management. One of my favorites is the pictogram, and these are powerful tools for conveying information. In a real world scenario, a healthcare provider may use a pictogram in patient education materials to illustrate dosage instructions for medication, showcasing preventive measures or conveying key health related statistics. Pictograms can really, really enhance an understanding, especially for individuals with varying levels of health literacy, or even if there's a language barrier. And that makes them a valuable tool for effective communication in healthcare settings. We also have a scatter diagram, and this shows the relationship between two numerical variables. It helps determine if there is a correlation, but not necessarily a cause and effect relationship. Tight clustering in a certain direction indicates a relationship. The closer the points look like a line, the more likely the two characteristics are correlated. We look at a positive slope means a positive linear relationship, while a negative slope means a negative linear relationship. For example, with the scatter diagram, it can be used to explore the relationships between the amount of exercise individuals engage in and their overall health outcomes. The x-axis might represent the weekly hours of exercise. The y-axis could represent health indicators, blood pressure, cholesterol levels, even BMI. And this can all help healthcare professionals understand if there is some type of correlation between physical activity and their actual health status. All right. So we've got all the information. We know what we're actually putting in some type of presentation. We have an understanding of what information would go with what data display. But we have to talk about preparing the report. The last part of the chapter that we're covering this evening is preparing reports. Writing effective reports is so important in any workplace, not just healthcare, in any workplace. So, to achieve this, you're going to tailor your report to your audience's preferences. In healthcare administration, reports should align with facility standards. So that means you're going to be reviewing previous reports because that's going to give you very important, valuable insights. Now, remember, effective communication is always going to be the key to success. When you craft a persuasive report, you are actually ensuring that your message is heard loud and clear. So the chapter talks about some general guidelines. When writing a report, include a clear title. Let them know what you're talking about. Use a table of contents for longer reports so that there may be something in particular that one individual is like, I got to know where this is, and they're able to go and find it. Introduce why you're even making the report, especially when it comes to formal reports. Use clear titles to divide narrative, tables, and graphs. Write in a style that's appropriate for your workplace. That's huge. And then you want to be objective, bias-free language, and write in an impersonal style, like it's business. You don't want to put in, well, you know, your feelings were hurt when they took out the sock machine. I don't know, I'm just throwing that out there, right? You can say, well, with the sock machine not present, then you speak, and this is the graph, and this is what's going on. This is how morale is being affected. Okay. With that, be concise and explain any types of abbreviations or acronyms that are in your report. You're going to want to proofread, and then proofread again so that you can improve your grammar skills. Remember, to err is human. We're not going to be perfect. So you want to just go through. I would even have second set of eyes go through, look at it, and then read your report carefully. And you may even want to have like a mini audience. Consider just reading it out loud and having that objectivity. Someone saying, hey, the message is good, or I'm not really sure you touched all the points that you clearly stated you were going to touch in the beginning and the purpose. Okay. Now, we are coming down to the end of the module. We have 2 weeks left. And you guys are doing really well. Keep it up. You have been in the statistics class, which is a lot of math, and you're still kicking it. You're still doing it. All right. With that, I have a Quizlet for y'all that y'all can kind of work on, especially since our final is cumulative. This will help you to kind of get ready. If you are able to get on, I'm not sure, there's 3 of us here. I'm not sure if you're on your phone, I know you're not going to be able to, but what I'll do, if Miss Joanne, if you're able to join, I am going to kind of just show everybody. I'm turning this off, guys. Sorry. I'm going to show everyone what this Quizlet is. Okay. So I'm going to open up a new window and join myself. We need at least 2 people. And then I'm going to have it. Like, my goal is not to answer any of the questions correct. I'm going to try not to. I'm just going to kind of go over. Oh, and she beat me. Okay. Hold on. HIT. I'm going to go and kind of just show you what the questions are. Okay. So my goal is not to, you know, answer anything in particular. Make sure you guys can see the 2 screens. Okay. We're going to create the game. There we go. So what you see on the left, and I turn the music off because that's the music. So I don't know if that would be too much. I usually kind of just mute it. But what you see on the left, she may not have these same questions, okay? But I kind of wanted to just show you how to kind of break these down. There are tons of concepts, but you're only going to see 12, okay? Really important. So I'm just going to go through and not even kind of look, just pick, okay? Boom, I got it. So I'll observe, oh, try not to say it because I don't want to mess up her thinking, but have another question, okay? Just going through, all right? I said I wasn't going to try to answer these correct, sorry. Okay. Now, keep in mind, let's say no worries, no worries. You can still see the screen, correct? Kind of see, hopefully. Okay, perfect. So, Miss Joanne unfortunately got kicked out, technology, but I'm just going through and just answering the questions. And what happens is you guys can challenge each other as well. I am going to try to master Kahoot. But right now I'm really comfortable here with this. But then you're going through and you're looking, you're just going through. And when you get a question wrong, what it does is, let me get a question wrong really quick. Okay, hold on. Let me try. It's like I want to, but I'm like, oh. All right. Close my eyes and just pick something. Okay, boom. So as soon as you get the question wrong, then the correct answer comes, and then you go back down to 0 in this particular case, but then you get to keep going. So it kind of really helps when, especially as we start to get closer and closer to finals, I'm going to be throwing a lot of different little Quizlets at you guys for you guys to have as additional resources. And some of them even do have where you can calculate. Okay. Now, if you guys remember, let me end the game and close it, quit the game. So with this, there are 44 terms. All right. And the one thing that I really do love, make sure you guys all got it, is the different ways. And so these two are new. They have categories now where you can add two or more players or groups or teams as well. So I'm just going to put in HIT 500 and just see what this is about because this may be something that we like. Okay. You can add more players and then categories in a group for a classroom. I'm the host. There's a quick little video where you can break things down. You have 10 to 20-minute games, team gameplay, or single. You do not need to log in and you don't really have to worry about anything. It's almost like a Jeopardy. So that's pretty cool. And we'll probably try that as it gets closer and depending on how many people we have. Blast is also something that's very new where again, you need more than two people where you kind of get the information and you're kind of blasting. It's like a game and you're able to, as a team, kind of work it out like just like in a break room, right? But you're doing it as a team and you're just working it out. Okay. With that, for those of you who are watching the playback, why is it important to present health statistics clearly? How does well presented data contribute to better decision making and outcomes in healthcare? Our math trivia, the smallest perfect number is 6. And pure mathematics is, in its way, the poetry of logical ideas. We went over chapter 11, all about presentation of data. We had a quick Quizlet game, and this is our wrap up. Of course, I had to be extra because it is my birthday, but um, you know, with that, what questions do you have for me? So far, it's been a blessing. It's been pretty good day. Relax, chill, teach a couple classes this evening, which I enjoy. And yeah, nothing else. Okay. Well, with that, next week, y'all, is surveys. So the surveys do open up, and y'all know we do want to hear from you. Good, bad, let us know. We cannot get better if we don't know. I do want to thank you guys all for being able to attend. Miss Joanne and Miss Rosie, thank you so much. I know that there's so many things going on, and I definitely appreciate you guys being here. For those of you who are watching, make sure that you do check out that archive. I do want I need an international spell check. I know I do too. Um, I do want you guys to have a wonderful rest of your evening, wonderful rest of your short week. Try to have a good weekend. And if you guys do need anything, I don't care, let me know. And I do look forward to seeing everyone who can attend week 10's live session. Good night, everybody.